Good morning students. Welcome back to physics online class. Hope you are safe and good by the grace of God. As per the timetable, next week you are going to write the online exam, is it? Are you preparing well? Okay, good. Dear students, you have to be serious in your studies. Don't waste your time. Whenever you are getting time, you have to prepare and write well. And last week, I completed the second chapter. In this, what are the things we learned? Have you remember? Yes, defects of eye. What are the defects of eye? Myopia, hypermetropia, presbyopia, and astigmatism. And also we discussed microscope. What are the types of microscope? Simple microscope, compound microscope, and traveling microscope. And last we studied about telescope and different types of telescope and what are the uses. So up to this you have to be prepared well and you have to write the exam. Okay. Today we are going to discuss the same chapter, example problems, and also we are going to mark the book evaluation questions. Okay. Now all of you take your book, page number 28. First problem, example 1. What they given there? The light rays travel from vacuum into glass whose refractive index is 1.5. If the angle of incidence is 30 degree, calculate the angle of refraction inside the glass. So first you have to read the problem carefully and you have to write what is given data. Okay. What's given here? Refractive index. You all know that what is refractive index. Refractive index you can represent the value 1.5 and it can be represent the letter mu. So mu value they given 1.5 and angle of incident is 30 degree. Angle of incident I is equal to 30 degree. Calculate the angle of refraction. So we have to calculate angle of refraction. See, to calculate this angle of refraction, here we have to use Snell's law. Have you remember what is Snell's law? Ratio of sine of the angle of incidence to the sine of the angle of refraction is equal to refractive index of the second media with respect to the first media. So sine I by sine R is equal to mu 2 by mu 1. Okay, this is the formula. So here we are going to use this formula and we can find the value of angle of refraction. So angle of incident I value given. How much? 30 degree. And the refractive index here they given 1.5. But we know here two values are there. Is it mu 2 by mu 1. So here what is mu 1 and what is mu 2? See, this mu 1 represent the refractive index of the air. Okay. So the value of mu 1 is equal to 1. If it is a air medium, the refractive index value is equal to 1. So you have to take mu 1 is equal to 1. And mu 2 is equal to the refractive index of the glass, that is 1.5, that is given here. Okay. And here substitute all this value and we can find the value of angle of refraction. Okay. See students, you have to write this answer in a classwork note. Okay. So take a classwork note and write down this problem and you have to write this answers. First you have to write given. What is given here? Refractive index of glass mu is equal to 1.5. So here mu means this refractive index of the second medium. Okay. So mu 2 we have to take. And angle of incidence I is equal to 30 degree. Angle of incidence is equal to 30 degree. What we have to find? To find angle of refraction or value only are going to find. So already I told which formula we are going to use here. Snell's law. Okay, as per the Snell's law, sin I by sin R is equal to mu 2 by mu 1. Okay, so what's the value of mu 1? Refractive index of this air, that is equal to 1. Okay, and mu 2 value already you know, that is 1.5 here they given, and we have to substitute here sin I by sin R. Sin I means what do you have to substitute? Sin I, angle of incidence, that is 30 degree. So in the place of sin I, here you have to substitute sin 30 degree divided by sin R. That value we are going to find is equal to mu 2. Mu 2 value, refractive index of glass 1.5 divided by mu 1, refractive index of air, that is 1. Okay. So you all know that what is the value of sin 30 degree. What's the value of sin 30 degree? Sin 30 degree is equal to 1 by 2. Okay, sin 30 degree 1 by 2. Okay, so you have to substitute sin 30 degree value is equal to 1 by 2. Okay, and sin R we are going to find. So we have to substitute here, just cross multiply. Okay, 1 into sin 30 degree is equal to 1.5 into sin R. Okay, so sin 30 degree value is 1 by 2. Now we have to substitute this 1 into sin 30 degree. So 1 into 1 by 2, and we are going to find the sin R, isn't it? So take the sin R that side, and 1.5 will come in the denominator. Okay, so 1 into 1 by 2 divided by 1.5 equal to sin R. Otherwise we can write sin R is equal to 1 into 1 by 2 divided by 1.5. Sin 30 degree divided by sin R equal to 1.5 divided by 1. Okay, 1 into sin 30, just cross multiply it, 1 into sin 30 degree. So sin 30 degree value, you all know that 1 by 2. Okay, 1 by 2 divided by, the whole divided by this 1.5, just take in the denominator, 1.5 is equal to sin R. Okay, now next step, 1 by 2 into 1.5 equal to sin R. Okay, so 1 by 2 into 1.5. So 2 into 1.5, what's the value? Is equal to 1 divided by 3. Okay, so now sin R is equal to, we can get 1 by 3. Okay, so it is equal to 1 by 3 means you all know that is in 0.333. It will goes like this, and we have to find the value of R, angle of incidence. R is equal to, take this sign that side, so it will become inverse. Sine inverse of 0.333. Okay, here point, sine inverse of 0.33. Okay, now you have to check this value of sine 0.33. Okay, natural sines value, you all know that logarithmic table, you have to take it and you have to see the value of 0.333. For that, what is the corresponding angle, just you have to check. Okay, if you are seeing that values, we can get the angle is 19.45 degree. Okay, for 19.45 you are getting this value, what is 0.33. Okay, so this is the angle of refraction, 19.45 degree. So write the step. Sin r is equal to 1 by 2 into 1.5. If you are multiplying 1.5 into 2, 3, isn't it? So sin r is equal to 1 by 3 means you all know that if you are dividing, what will get? Okay, 0. Here 0. Then here what? 3. 3 3s are 9. Here 1. So it will goes like this. Okay. So 3 3. Okay. So sin r is equal to 0.333. So it will go like this. And from this you can calculate the angle of refraction r. So take the sine value here. So it will become inverse. Sine inverse 0.33. Now you have to check the logarithmic table for this value. What is the corresponding angle? Okay. So you have to take your logbook and check this value. Already you learned 9th standard max, is it? So 0.33, that value, what corresponding angle is there? Okay, so it is 19.45 degree. Okay, so angle of refraction is equal to 19.45 degree. Okay, this is the first problem. Now look at the second problem. Just read. A beam of light passing through a diverging lens of focal length is 0.3 meter appear to be focused at a distance 0.2 meter behind the lens. Find the position of the object. So what and all given here? It is a diverging lens. Okay, diverging lens means you all know that it is a concave lens. So concave lens, the focal length is negative. Okay. So here the focal length value they given 0.3 meter. Okay. So you have to take the focal length f is equal to minus 0.3 meter. Okay. And at a distance of 0.2 meter the images appear. Okay. So 0.2 meter the images appear. So we have to find the position of object position only we have to find. Okay, just listen here. It's a concave lens. Okay, so here the image is appeared. Okay, 0.2 meter. So we have to find what is the object distance we have to find. Okay, first you have to write the given data. What is given? Focal length of the concave lens 0.3 meter and this is the image distance. Okay, so appear to be focused at a distance 0.2 meter they given. No, it's a image distance, v value they given. Okay, and we have to find the value of u, object distance. So you all know that what is the formula we can use here? Yes, lens formula. Okay, what's the lens formula? Have you remember what we learnt? 1 by f is equal to 1 by v minus 1 by u. 1 by f is equal to 1 by v minus 1 by u. Okay. So f means focal length, v is the image distance and u is the object distance. Write the given data first. Focal length f is equal to minus 0.3 meter. Why this minus? It is a diverging lens. Diverging means concave lens. The focal length is negative. And the image distance v is equal to minus 0.2 meter. Here why we are writing this minus here? Because the image is formed behind the lens they given. Okay. So the image is formed behind the lens. So behind the lens means here only the image is there. Okay. Behind the lens. So we had to be put the minus symbol. You all learned the sign convention, rules and sign convention, Cartesian sign convention. As per that, whatever distance we are measuring along the direction of incident light means positive, opposite the direction of incident light means negative. So we have to measure like this, the image distance from here to here, the image distance. So this is the opposite direction of the incident light. So we have to put the minus symbol. Okay, so minus 0.2 meter. Okay, and we are going to find the object distance u. So we have to write the formula first. 1 by f is equal to 1 by v minus 1 by u. Okay, but here we are going to find the value of the object distance. U value only are going to find. So take this minus term that side. Okay. So 1 by u, if minus 1 by if you are taking that, so it will become plus. Okay. And this 1 by f, just you have to take this side. So this will become minus 1 by f. Okay. So 1 by u is equal to 1 by b. This minus 1 by f. Now we have to substitute these values. Okay. So v value what is there? Minus 0.2 meter. F value what is there? Minus 0.3 meter. Okay. Just to substitute this value, 1 divided by minus minus 1 by minus 0.3. Now this minus and minus will become plus. Okay. This minus and minus will become plus. So first I have to write this denominator minus here. Minus 1 by 0.2 and this minus minus plus 1 by 0.3. So this is this 2 is decimal numbers, isn't it? 0 point and here also 0 point is there. So we cannot take the LCM. So you have to make into whole number. So how to make into whole number? You all know that both sides multiply and divided by 10. Okay. So if you are multiplying divided by 10, what we can get? Here minus 10 by 2. Minus 10 by 2. Here plus. Here if you are multiplying with 10. Isn't it? 1 to 10. 10 divided by. Here also 0.3 into 10. Okay. So it will become 3. Okay. Next you have to take the LCM for 2 and 3. If you are taking the LCM for 2 and 3, it will get 6. Okay. So 6 is the LCM. So next what we have to do? So this 10. So if you want to take the same denominator, so you have to multiply. Okay. 2 3s are 6. So the same number you have to multiply here also. You all know that is it. So 10 into 3. Here what will come? 2 into 3. Okay. So 10 3s are 30. Okay. Minus 30. Similarly here 2 3 2s are 6. So here also multiply with the 2. 10 2s are 20. So minus 30 plus 20 divided by 6 is there. So minus 30 plus 20. What's the answer? Yes, this is the big number. So you have to put this symbol, isn't it? Minus 10 divided by 6. So 1 by u is equal to minus 10 by 6 means, what is the value of u? 1 by u means minus 10 by 6. So you have to take u. Just you have to take the reciprocal. So minus 6 by 10. So if you are dividing minus 6 by 10, you can get minus 0.6. So this is the answer. So object is placed the distance of minus 0.6 meter. Okay. So you are getting this minus sign. Why you are not know that? Okay. The object should be at the left side of this lens. Okay. That's why we are getting this minus. So what's the answer? The object distance is minus 0.6 meter. Okay. I hope you all understand that first two problems. Have you all understood? Okay, next we are going to the third problem. A person with myopia can see objects placed at a distance of 4 meter. If he wants to see the object at a distance of 20 meter, what should be the focal length and the power of the concave lens he must wear? So you all know that myopic is a type of defect. We can see the nearby object and we cannot see the distant object. Correct? Okay. And he has to wear the what type of lens? Concave lens. Okay. So in that concave lens, what's the power? Okay. We have to be find. So myopic persons can see the object placed at a distance of 4 meter. So we all know that formula, isn't it? How to write that formula for correcting that focal length? What's the formula? F is equal to xy by x minus y. Okay, this is the formula. Okay, First you can write the given data. So x means that person how much distance he can able to see. Okay. So he can able to see the distance up to what meter they have given, 4 meter. Okay. So placed at a distance, myopic person can able to see the object at a distance of 4 meters. So x value is equal to 4 meter. X is equal to 4 meter. But he wants to see the see the objects at a distance of 20 meters. So here y value also they given 20 meter. So what we can to find the focal length of the correction of lens. Okay, focal length of the correction of lens. What's the formula? F is equal to xy by x minus y. F is equal to xy by x minus y. So x value here 4 meter, y value 20 meter they given. So easily we can find the focal length. Okay, x in the place of x, what we can substitute now? 4 into y value is 20 divided by 4 minus 20. Okay, x minus y, so 4 minus 20. So 4 into 20, how much? Yes, 80 divided by 4 minus 20, 11. Okay, minus 11 because 20 is the big number. So minus 16. Okay, so 4 minus 20 minus 16. Now you can cancel this 2. Okay, so if you are cancelling this 80 divided by 16, what we can get? Here 40, 8 2s are 16, 20, here 4 2s are 8, again we can cancel now, 10, here 2, again 1 2 is 2, here 5. Okay, so f is equal to what value you are getting? This minus you have to take there. Okay, the numerator. So f is equal to minus 5. Now we got the focal length, but here's the question. We have to find the power of the concave lens. Okay, we have to find the power. Okay, power also you have to find. Okay, first you have to find the focal length, next only we can find the power of the concave lens. Okay, focal length, next here power, p value also we are going to find. Now tell me what's the formula for the power of the lens? What's the power of the lens? P is equal to, yes, power P is equal to 1 by f. Okay, so reciprocal of focal length is called as the power of the lens. So f value just now we found. What's the value of f? Minus 5. Okay, just you have to substitute here. 1 divided by minus 5. 1 divided by minus 5. So how to calculate 1 divided by minus 5? It's 5. So 1. Here 5. So put 0 here. Here 1. 0. 2 5s are 10. Okay. So what's the value? This minus is there, so you have to substitute this minus 0.2. Okay. Focal length unit is meter, but power of the lens, what is the unit of power of the lens? Diopter. The power of the lens is diopter. Okay, so you have to put the symbol D. Okay, so have you all understand? Okay, so this is the formula. F is equal to xy by x minus y. So for calculating the focal length of the concave lens of the myopic person. Okay, so you are getting this answer. Power of the lens P is equal to minus 0.2 diopter. Okay, minus 0.2 diopter. Next problem. Fourth problem. Okay, for a person with hypermetropia, the near point has moved to 1.5 meter. So near point has moved to 1.5 meter. Calculate the focal length of the correction lens in order to make his eyes normal. So just now we calculated the myopic eye. What's the focal length? And now we are going to calculate the focal length of the correction of the hypermetrophic eyes. Okay. So here what is the formula? We learnt already. Okay. So first you have to write the given data. The distance up to here you can see that is 1.5 meter. Okay. And the required distance is 25 centimeters. So this 25 centimeters is not given. But you all know that the near point of this eye is how much centimeter? 25 centimeter. Because that person can, if you want to see the nearby object, at least the distance should be 25 centimeter. Okay. That is the near point of this eye. Okay. Near point of this human eye is 25 centimeters. So this capital D value you have to take a 25 centimeter. See here one unit is given in meter, another unit is in centimeter. So M is the standard unit of this distance. Okay. So meter is the standard unit of the SI standard. So you have to change this centimeter into meter. So 25 centimeter is equal to how many meter? Yes, 0.25 meter. So you are going to calculate the focal length of the correction of this hypermetrophic eye. Okay, focal length of the correction of this lens. Okay, that is convex lens. Focal length we are going to find. So the formula is F is equal to small d into capital D divided by small d minus capital D. Okay, listen here. So this small d value here they given how much? 1.5 meter, and this the required distance, that is 25 centimeter. Okay, so capital D value is 25 centimeter. So you can substitute here. So 1.5 into 0.25, capital D value is in meter 0.25 meter. Okay, multiply divided by 1.5 minus 0.25. Okay, just if you are multiplying, what's the answer? If you are multiplying 1.5 into 0.25, what's the answer? 0.375. Okay, and just you have to be subtract 1.5 minus 0.25. Now 1.5 minus 0.25, if you are subtracting, what's the answer? 0.25. So the answer is 1.25. So here I write 1.25. Now if you are dividing this one decimal number, isn't it? So both the sides you have to multiply and divided by 1000. You have to make it into whole number and just you have to simplify this. Okay, and you can get this answer is 0.3 meter you can get. Okay, 0.3 meter is the required focal length of the convex lens. Okay, for this hypermetrophic person, what is the focal length he required? 0.3 meter. Okay, just you have to divide and check the answer. Now all turn this page number 29. Page number 29, evaluation, choose the correct answer. Okay, the first question, the refractive index of four substances A, B, C and D are 1.31, 1.43, 1.33 and 2.4 respectively. The speed of light is maximum in which medium they asked. Okay, A, B, C, D, like that 4 medium is given. So in that refractive index value also they given. So you have to find in which medium the speed of light is maximum. Okay, so how to find this value? Listen here. First you have to write that 4 medium A, B, C and D. Okay, A, B, C, D. In that each refractive index value also you have to write. For the medium A 1.31, for the medium B 1.43, the medium C 1.33 and for this medium D that is 2.4. Okay, so how to find in which medium the speed of light is maximum? See, you have to already learned one relation, isn't it? C is equal to mu is equal to C by V. That is refractive index and the velocity of this medium, it is inversely proportional. What's this meaning? velocity of the medium and the refractive index is inversely proportional. That is, the velocity is maximum means the refractive index should be low. Okay, which medium the refractive index is low? In that medium only velocity is maximum. Okay, so velocity and refractive index is inversely proportional. Okay, as per this relation, so here now we have to check which medium the refractive index value is low. Can you identify which medium the refractive index is low? 1.31, 1.43, 1.33, 2.4. So which is the lowest one? Yes, the first one. Okay, so here the refractive index is low. So in this medium the velocity is maximum. Okay, so velocity is maximum when the refractive index is minimum. Okay, so here, so this answer is medium A. What's the answer? Medium A. Okay, just you have to mark this question A. Second one, where should an object be placed so that a real inverted image of same size is obtained by a convex lens? Listen here, same size of the image. So which place we are keeping this object, we can get the same size? Yes, the object position should be 2f. Okay, or at the center of curvature. Okay, center of curvature or 2f value they given. So 2f, if you are keeping the object, we can get the same size of the image. Next, third one, a small bulb is placed at the principal focus of a convex lens. When the bulb is switched on, the lens will produce dash type of image. A small bulb is placed at the principal focus of a convex lens. When the bulb is switched on, so when the bulb is switched on, here what type of image is produced? Means parallel beam of light is produced. Okay, so when the bulb is placed at the principal focus of the convex lens, a parallel beam of light is coming from the bulb. So the answer C. Now fourth question, magnification of a convex lens is, what's the answer? Magnification of a convex lens. Okay, magnification of a convex lens is either positive or negative. Okay, option C, either positive or negative. Then fifth one, a convex lens forms a real diminished point-sized image at the focus. Then the position of the object is at infinity. See, if the object is placed at infinity, then only we can get the images at the focus. Okay, so the position of the object is at infinity. Option B. Now one problem, power of lens is -4 diopter, then its focal length is dash. So power, what's the formula for power? P is equal to 1 by F. Okay, power P is equal to 1 by F. But here we have to find the focal length. F value only want to find. So take this F here. So F is equal to 1 by P. Okay, F is equal to 1 by P. Here because P value only, the power of the lens -4 diopter they given. Okay, so F is equal to 1 by P. Right. Now P value what's given? 1 by -4. Okay, 1 divided by -4. What's the answer? Yes, -0.25. Okay, write the formula near it. Okay, and you have to do the sum and write the answer. Okay, -0.25 meter. Option C. Seventh one, in a myopic eye, the image of the object is formed in front of the retina. Myopic person, where is the image is formed? In front of the retina. Eighth one, the eye defect presbyopia can be corrected by what type of lens? Presbyopia? Bifocal lens. Okay, bifocal lenses. Option D. Now this ninth one, which of the following lens would you prefer to use while reading small letters found in a dictionary? Okay, so small letters found in a dictionary, what type of lens we have to use? So if you want to see the nearby object, you all know that that convex lens is used, isn't it? Convex lens of focal length 5 centimeter. See, focal length reduced means that magnification power will be increased. So in this option, here is the reduced focal length, okay, that is 5 centimeter. Okay, the magnification power is increased by reducing the focal length. So option A, convex lens of focal length 5 centimeter. If VB, VG, VR, that is velocity of this blue light, green light and red light, be the velocity of this blue, green and red light respectively in a glass prism, then which of the following statement gives the correct relation? See here, the velocity, the option C is the correct answer. And the velocity of the blue light is less than the velocity of the green light, and less than it is the velocity of the red light. Okay, so option C. Now fill in the blanks. Path of the light is called dash. Ray of light. Path of light is called what? Ray of light. The refractive index of a transparent medium is always greater than 1. The refractive index of a transparent medium is always greater than 1. For air medium, the refractive index value is 1. Other medium, the refractive index value is greater than 1. If the energy of the incident beam and the scattered beam is same, then the scattering of light is called dash scattering. Elastic scattering. See, incident ray of light and the scattered ray of light will have the same energy, means what type of scattering? That one, elastic scattering. Okay, it is elastic scattering. Fourth one, according to Rayleigh's scattering law, the amount of scattering of light is inversely proportional to the fourth power of its dash wavelength. Okay, you all know that. What is Rayleigh's scattering law? Amount of scattering of light is inversely proportional to fourth power of its wavelength. Okay, amount of scattering of light is inversely proportional to, amount of scattering of light is inversely proportional to 1 by lambda power 4. Okay, the scattering of light, yes, also we have to be mentioned. Okay, so 1 by lambda power 4, it is wavelength. Then question number 5, amount of light entering into eye is controlled by dash. Iris. Okay, iris. I or IS. Amount of light entering into the eye is controlled by iris. Now the third Roman letter, true or false. Velocity of light is greater in denser medium than in the rarer medium. It's false. So the correct option is lesser in the denser medium. Velocity of light is less in the denser medium. The power of a lens depends on the focal length of this lens. Power of a lens depends on focal length. That is true. Increasing the converging power of eye lens causes hypermetropia given. So the answer is false. So that is, increase in converging power means that causes what? Myopia. So cut this and write it, myopia. The convex lens always gives a small visual image. That is true. Convex lens always gives a small visual image. True. So now match the following. Retina, screen of the eye. Pupil, pathway of light. Ciliary muscle, power of accommodation, is controlled by ciliary muscle. Myopia, far point comes closer. That's why they cannot be able to see the distant object. Hypermetropia, near point moves away. Near point moves away. Assertion and reason type. First question. If the refractive index of the medium is high, the velocity of the light in that medium will be small. Reason, refractive index of the medium is inversely proportional to the velocity of this light. Here which option is the correct one? See, assertion is if the refractive index of the medium is high, the velocity of the light in the medium will be small. That is true. Okay. Refractive index is high means velocity will be less only. Okay. So assertion is correct. And reason, refractive index of the medium is inversely proportional to velocity of light. So both also correct. So which option here we can choose? Both assertion and reason are true, and the reason is the correct explanation of assertion. So answer A. Second one, myopia is due to increase in the converging power of eye lens. Reason, myopia can be corrected with the help of concave lens. Here the assertion is true, isn't it? So the option B, here what they given, both assertion and reason are true, but the reason is not correct explanation of the assertion. Okay, myopia can be corrected by concave lens, but for this assertion, this reason is wrong. Okay, so B, option B. Now this Roman letter 6, answer briefly. Already you marked, I think, just you have to note it down. Those who did not mark, write the page number. What is refractive index? It is page number 17. States Snell's law, the same page number. And this third one, draw the ray diagram to show the image formed by the convex lens when the object is placed between F and 2F. This question page number 21. Okay, so page number 21. So mark this one, object placed between F and C. C and 2F same only. So I have to mark this paragraph and this ray diagram. Okay, page number 21. Then define dispersion of light, that is page number 17. And state Rayleigh law of scattering, page number 18. And differentiate convex lens and concave lens, already marked, 23, page number 23. Which is the power of accommodation of eye, that is given in page number 24. Okay, power of accommodation paragraph. Okay, power of accommodation, already you marked this page number. The ability of the eye lens to focus, this paragraph alone you have to mark. Okay, power of accommodation, this paragraph you have to mark it. Okay, page number 24. Then 8th question, what are the causes of myopia, that is page number 25. Okay, page number 25, causes of myopia, just you have to mark it. Next question, why does the sky appear blue in color, page number 18. Okay, page number 18. Only this question I did not give, I think. Why are the traffic signals red in color? Okay, so traffic signal, you all know that the red color light is used to stop the vehicles. Okay, what is the reason? Okay, this one I will give the notes. Okay, now you have to take your class note and you have to write this answer. Why are traffic signals are red in color? Write down this answer. In traffic signals, red color light is used to stop vehicles because it having longer wavelength. Okay, this is the first point. Traffic signal, red color light is used to stop vehicles because it having longer wavelength. Next paragraph, the light with longer wavelength will undergo lesser scattering. So red having the longest wavelength, so the scattering power will be less. Less amount of light only will scatter. The light with longer wavelength will undergo lesser scattering. Hence, it is visible from a longer distance. Hence, it is visible from a longer distance. So, it can easily pass through, the red color light is easily pass through fog, smoke, through rain, etc. Okay, so the red color light only easily passes through. So the red color light is able to travel longest distance. Longest wavelength is there, so it can able to travel long distance and less scattering power is there. So it can pass through fog, rain, smoke, etc. So last paragraph, red color light is able to travel longest distance through fog, rain, smoke, etc. Okay, please write down this answer in your class note. Okay, along with that the problems you have to write this answer. Okay, next Roman letter 7th one, detailed answer. Already you marked. List any 5 properties of light. It is given in page number 16. Second question, rules formed by the convex lens with the help of ray diagram. It is given page number 20. Differentiate the eye defects, myopia and hypermetropia. It is given page number 25. And explain the construction working of a compound microscope. It is given 26 and page number 27. Already you marked. Okay, once again you did not mark. Those who did not mark, just you had to mark this page number and you have to study. Okay, so the Roman letter 8, the 2 problem is there. This 2 problem I will give you in the next class. Okay, so you have to be, this book evaluation is not given for your exam. I think only that page number I given, that one you have to be learned well. Okay, thank you students, all the best for your exam. Okay, thank you.